equations and inequalities. We're going to look at mathematical operators from the very basic upwards. Mathematical operators come in a variety of forms. They're also paired together. So if you think about it, you did addition first, and then soon after was subtraction. You did multiplication, and then you found a way back called division. But there are other pairs as well, like the square root and the square go together. The cubic root and the cube go together. The xth root and y to the power of x. And very often in your calculator, these are seen as one being the inverse or the second function of the other. So sine and sine inverse, cosine or cos and cos inverse, tan and inverse tan. And also on your calculator, you'll see a function called log, L-O-G, with 10 to the power of x, or natural log, and e to the power of x. And these are paired, and they're linked. Really, one undoes the other and allows you to unscramble something by getting back, by unlocking what the first one did. So I'm going to look at something very, very straightforward, and that's just x plus 2 is 5. And if I were to say x plus 2 is 5 to you, my guess is that you'd immediately say x is 3. You've done it so many times that you know the answer is 3. And instinctively you're saying, well, x plus 2 is 5, it must be 3. But if we look at it more slowly and we say, what's really happening here? What you're saying is, I like x on the left-hand side, okay, but I just prefer if it was just x equals. And I don't like this plus being on the same side. I wish it was out of the way. So what you can say is you say x plus 2 is 5, but maybe x plus 2, and if we think of plus and say, well, what's the opposite of plus? Well, that would be a minus. So if we said x plus 2 minus 2, that would get rid of the 2. But if we get rid of the 2 on one side by adding minus 2, we must add it on this side. 5 minus 2. Well, these two 2's cancel. And that's not surprising, because that's why you did it. And 5 minus 2 on the calculator, well, that's just 3. So I've got the same answer as x plus 2 is 5 and x is 3, as you would do in your head. I just did it more slowly. But I just undid or went through the processes step by step. Now, let's continue that and say y minus 3 is 8. What's y? Well, y minus 3, the opposite of minus is plus. Do it on both sides. Y is 11. We move now to multiplication, and we say what happened then when we were moving through primary school, and we went from addition, subtraction to multiplication. 3x is 12, x is 4. You know that. But how do we get that? Well, we prefer x on the left-hand side on its own. But this 3 is in the way. This time it's a multiplier. So to get rid of the 3, we will divide by 3. And if we do it on the left-hand side, we must do it on the right-hand side. So 3x over 3 is 12 over 3. X is 4. With division, y over 5 is 10. We don't like the 5 on the bottom. Let's divide. It's dividing. So the opposite of that must be multiplying. So 5 times both sides would still be okay. And the 5's would cancel, and we get y is 5 times 10, which is 50. Now, we move through primary, and we're moving up now, and we're looking at, say, later years in primary, and we're saying, what about squares? Well, x squared is 9. I don't like anything on the left-hand side unless it's just x. I don't like the 2 there. So how will I get rid of the 2? Well, if it's a square, squared, well, the opposite of that must be the square root. So if I take the square root of both sides, the equation still holds. But the square root of a square clears it. That's the unlocking bit. So the square root of a square is just x. So x is plus or minus 3. Similarly, if somebody says the square root of x is 5, I don't like the square root there. The opposite of a square root would be to square it. So if I square both sides, the equation still holds. And the square of a square root, x is 25. You knew this. But we now move to cubes, and we say x cubed is 8. How do I get rid of a cube? Well, the unlocker is the cubic root. The cubic root of x cubed is the cubic root of 8. The cubic root of x cubed, I don't really have to know what it is, really. All I know is that gets rid of it. I know it's just x. What I need to know is the cubic root of 8. And that's done on a calculator. I put in 8, press cubic root, and I get 2. If somebody said the cubic root of x is 3, what's x? I don't know. But I know if I cube both sides, I'll get rid of that cubic root. And I'll get x is 3 cubed. That's on a calculator. That's 27. So we now move a bit further and we say, okay, what about x to the power of 10? X to the power of 10 is 1024. I just want x there. What gets rid of a power to the 10? Well, we can look it up way back here in our tables. And we can say the one opposite x to the power of, say, y to the x or y to the x is x root of. So if I take the 10th root of x to the power of 10, I get the 10th root of this. That's just ugly, but it just means that I've left with x. So x is the 10th root of that. That's a calculator. 1024, press 10th root, I get 2. The 5th root of x is 2. Don't know what that is, but I do know that if I do both sides by to the power of 5, which I do here, that'll all go away, and I'll just be left with x. And 2 to the power of 5 is 32. I now want to show the power of trigonometric functions and the use of exactly that unlocking key here when it comes to sines and inverse sines. Some people look at sine of an inverse sine and they say, I don't like that equation. But I do know that one is the opposite of the other. So sine of sine inverse of theta is just theta. Cos of cos inverse theta is theta. Tan of tan inverse is theta. And similarly, the inverse sine of a sine is theta. The inverse cos of a cos is theta, and the inverse tan of a tan is theta. Why would I use this? Well, now we move on to some questions. And we say, imagine now in your exam, you're faced with example 1, and you're told that tan inverse x is 45. And you say, yeah, I have the left-hand side all right. There's an x on the left-hand side, but there's a bit of other stuff there that I don't really need with the tan inverse. So the first thing I'd say is, what gets rid of a tan inverse? Well, the opposite must be tan. So I'm going to take the tan of the left-hand side, and then I must take the tan of the right-hand side. Well, the tan of a tan inverse, I haven't really thought of before, but I don't really have to because one is the opposite of the other. So whatever it is, it just gets rid of it. So I now have x equals tan 45. 45 I hit on the calculator, press tan, and I get x is 1. So this question now becomes much easier. I just find the unlock button and just get rid of it. I can do the same for sine. If somebody said the sine of x is 0.5, what's x? I don't know. But I know what will get rid of a sine. The opposite of a sine is sine inverse. So if I take sine inverse of the left-hand side, I can take sine inverse of the right-hand side. And the sine inverse of a sine, I don't really care what it is because all I know is they cancel each other out. That's why I chose it. So x is now sine inverse 0.5. 0.5 calculator, press sine inverse or inverse sine, and I get x is 30, provided I have the calculator set on degrees. We now move to another topic called logs and exponents. Somebody says that log, log of x, is 2. How do I get x? I don't know. But if you look at your calculator, the inverse of log is 10 to the power of. So 10 to the power of log x is 10 to the power of 2. 10 to the power of log, they cancel. X is 10 to the power of 2. X is 100. And if you press log 100, you get 2. Similarly, if somebody said 10 to the power of x is 1,000, find x, and this question comes up, not the log part, but the other part, and say 10 to the power of x is 1,000, what's x? What you can do is just take the log of both sides. The log of this is the log of this. That's going to cancel. And you just find that x is log 1,000. On your calculator, x is 3. And 10 to the power of 3 is 1,000. There are two types of logs on your calculator. One is called log, the other is called ln, sometimes written as log with a little e on it, whereas the other log is sometimes written with a log 10 on it. But most calculators would say ln rather than log. So if somebody said that ln x was 3, you just do the opposite. E to the power of it, or inverse log, would be e to the power of this. Therefore x is e to the power of 3, and you can calculate that on your calculator. Similarly, if somebody said e to the x is 12, I don't like e, but the inverse is log, so I take the log of both sides, the log of 12, x is therefore log 12. So effectively what we've done there is we have looked at it and said, throughout all our mathematical education, there have been operators. There's the lock and the unlock button. And any equation throughout any part of your course on either paper, all you've got to do is say, what's in the way, what unlocks it, unlock it, and move on. And it's as straightforward as that. And we'll do that in all the equations. But there's the pairs. You know them anyway, the plus, minus, the multiply, divide, etc. And the others you'll know from your calculator because it's the inverse of the other one. So sine, sine inverse, tan, tan inverse, log, 10 to the x, or ln, and e to the x.